Good afternoon, all. Am I audible? Am I audible?
पापा से बात कर ले, मेरे को तो इधर भी भेजने को तैयार है।
Are you? Mute from your side.
पापा से बात
Arya, Somal, mute from your side.
तो तू खुद भी तो कोई नहीं है, मेरे को तो तेरा
Somal, I'm facing noise. Yeah. So, good afternoon, all. In the last lecture, we started with cumulative probability distribution and probability distribution of a random variable. Okay. For discrete as well as continuous random variable, you should understand what is meant by a probability function and cumulative probability function. Probability function is also called as probability mass function or probability density function. So today I'll be starting with the whiteboard. Let me share the screen first. I'm sharing my screen. Just tell me whether the screen is visible or not. Is my screen visible? Yes.
Yes, ma'am.
Just a minute. Some updates are coming. Let me close. Yeah. Thank you, Pratik. So on the whiteboard, I have written few things just to save the time. So let me just start with the first slide of today's lecture. So is the slide visible? Whiteboard slide. I hope it is visible. So you just recall, for a continuous random variable capital X is equal to X, the probability density function, or you may simply say probability mass function, or just simply probability function, small f of X. So probability density function we denoted by small f. It satisfies the following three conditions. So we discussed it last time. First is positivity, fx is greater equal 0. Secondly, integral from minus infinity to infinity of the probability function is 1. In case of discrete function, the probability is sum up to 1. And the third condition is probability of the random variable, value of a random variable lying in between a and b is the integration of that small fx from a to b. Now we also have seen what is meant by cumulative distribution capital F of x of a continuous random variable capital X, which is having density function small f of x. So what is capital F of x? Capital F of x is the probability of capital X which is less than or equal to x. So in case of discrete function, discrete random variable, it is sum. What is that? It is sum of f of x for all t less equal x. So you have to add the probabilities till that x. This is how to define cumulative distribution of a continuous random variable capital X. So all of you have understood these two things which I am recalling from the last lecture? Yes or no? You got the difference between small f and capital F functions? Yes. Few thumbs ups are coming. So I hope I should proceed. Okay, let me go to next slide. So the very first statement, just note. Okay. So just note that probability of the random variable capital X which lies in between A and B is what is meant by this probability. Look at this previous slide. What is that? Just a minute. Why the touch is not working? So what is the probability that your capital X lies in between A and B? It's the integration. We also discussed in the last lecture that if suppose this is your graph of small f of x probability function, okay, Then suppose I take 2 points A and B in a domain. Domain is of random variable capital X versus you are plotting the probability function. We have also seen pictorial representations in terms of probability, histogram, bar chart, etc., in the last lecture. So what is meant by integration of some function? It is area under the curve, isn't it? That everybody knows. And suppose I integrate small f of x from A to B. Let me just draw these boundaries, and integral from A to B of small f of x dx is the shaded area under the curve, right? So everybody knows this. Integration is area under the curve. Suppose we are integrating from minus infinity to infinity, because we define the random variable from minus infinity to infinity, and cumulative distribution function also in terms of small f from minus infinity to infinity. We have also seen those things in the last lecture. So when I integrate from A to B, can you interpret in terms of capital F of x? What is capital F of x, students? Capital F of x is, let me just go to the new page. Capital F of x is the cumulative distribution function, which is probability that capital X is less equal x. Okay. And in the case of continuous random variable, it is integral from minus infinity to that x value up to which you are summing up the probabilities. In case of discrete, it is summation of fx up to that x. Correct? Therefore, it is called as cumulative. So this is in case of continuous random variable. Now, suppose I have to interpret probability of your random variable x that lies in between A and B in terms of capital F. What you will do? I know capital Fx is defined from minus infinity to x fx dx. So probability of capital X lying in between A and B, I can write, I know it is area under the curve. So I will integrate from minus infinity to B first, to that small f of x dx. And I will subtract. What you will subtract from this? What you will subtract from this? If you have to integrate from A to B. So A and B are here. And from minus infinity to infinity is your whole domain. I have to interpret this shaded area in terms of two improper integrals of first kind. You know what is meant by improper integrals of type 1 and type 2? You have studied that in UVC course. So from minus infinity to B, first of all, when I integrate, I know I am finding this area that I'm shading with blue color, whole area. From that, I have to subtract the integration from minus infinity to A. Means this part I have to subtract. Correct? So I should write it minus infinity to A f of x dx. Is this understood? Now what is this first integral in terms of capital F, students? This is capital F. The first integral in terms of capital F, what is that?
Capital F of B.
Yeah. So yes, correct, Arya. So here I should write t because your limit of integration and the variable of integration cannot be same. F of t dt I will write. Integral from minus infinity to x f of t dt. In fact, it is not having any problem because integration is independent of variable of integration. So even if I write x, it is okay, but it is seems to be what you can say mathematically conflicting because x is the variable of integration. At the same time, your upper limit is also x. Therefore, change this variable of integrations to some other variable name, say t. So yeah, so as Arya said, minus infinity to b fx dx in terms of capital F is nothing but capital F of B minus, similarly, second integral is capital F of A. Look at the upper limit of integration. And this is nothing but probability that your capital X lies in between A and B. So this formula you have to remember. This I have listed over here. So this is the first formula. The probability that your random variable lies in between A and B is value of cumulative frequency distribution of your random variable at B minus cumulative frequency of your random variable at A. So this first formula you have to remember. Second, from the definition of cumulative frequency distribution, capital Fx is integral from minus infinity to x f of t dt. So using fundamental theorem of calculus, FTC1, What you can say about small f of x? Suppose capital F is the integration of small f. What is small f in terms of capital F? Is the derivative. You know, integration and derivative are inverse operations of each other. Yes? Is the second part clear? Second note. Capital Fx is cumulative frequency distribution, which is defined as integral from minus infinity to x small f of t dt. Therefore, as capital F is the integral of small f, cumulative frequency distribution is the integration of your probability function. Then probability function is nothing but the derivative of your cumulative distribution function. Okay, so you remember capital F is integral of small f, therefore small f is the derivative of capital F, where small f is frequency probability function and capital F is cumulative probability distribution. So these two formulae you should remember, 1 and 2. Okay, let me go to next step. Let us take an example. Let me just read the question. I have written it already. The Department of Energy, DOE, puts the project on bid. Generally estimates what a responsible bid should be. Okay, so you call the estimate B as DOE determined the density function of winning bid is. So how the density function of winning bid is defined in terms of small f. So this is density function, means it's the probability function of the winning bid. What is the probability that bid will win? That is represented by this function. So you tell me this random variable is a continuous random variable or a discrete random variable, students? It is continuous, no? Because the probability function is having some law or formula or rule. So this is the probability function of the winning bid, small f. And the question is, so of course it is defined from 2b by 5 to 2b, 0 elsewhere. The probability of winning bid, if the winning bid actually it depends on variable y. If it lies in between 2b by 5 and 2b by 5, the probability is 5 upon 8b. Otherwise, the probability is 0. Now you have to, so you have given probability function small f, and how will you find out the cumulative probability function capital F of y? So just now we have seen that capital F is the integral of small f. So therefore, I have to just integrate this function small f of f. Okay. So we have to find out capital F of y. So the solution is capital F of y, I know, is the integral from minus infinity to y f of t dt, correct? By definition of cumulative probability function. And then you just substitute small f of t. So look at this small f of y, how it is defined. Actually, you have to integrate from minus infinity to y, correct? Somewhere you are having y, na? But you know your probability function is defined only on the interval 2b by 5 to 2b, correct? Otherwise it is 0. So only here it is defined on 2b by 5 to 2b. Only on this domain it is defined, 0 elsewhere. Here it is 0, here it is 0. So when you integrate from minus infinity to y, here, when I integrate from minus infinity to y, it is actually from 2b by 5 to 2b by 5 to 2b. And how it is defined? The function is 5 upon 8b. Because otherwise it is 0. Correct? 5 upon 8b is a constant function. It is independent of variable of integration t. So this is by definition given of small f. Correct? And just the question is just now to integrate. That's it. So that is your capital F of y. It's very simple. So it is 5t upon 8b from 5b by 5 to 2b. So this is equal to 10b upon 8b minus 25b. Sorry, what I have written? 5b by 2b by 5, no? काहीतरी चुकलंय. Calculations सांगा मला हे upper limit minus lower limit. 10b upon 8b minus what? Yes, what is the answer? What is the answer of this integration? Bola. You write down your answer in the chat box. Is your answer 1? Constant 1?
Ma'am, I think the capital F of y should be a function of y, but we are getting a constant, so I think we are doing something wrong.
So what is wrong? Can you trace it out?
Actually, while integrating, actually you have integrated from minus infinity to infinity only.
Yeah. No. Here, when I find out f of y, my upper limit of integration is y. So here I should not take 2b. Are you getting me? I have to find out cumulative frequency distribution till y, na? So let me just go to next page. So here, cumulative frequency distribution function we have to find, right? So capital F of y is probability that capital X is less equal y for a continuous random variable. So it is from minus infinity to y f of t dt. Up to here it is okay. Now you have to just put on f of t. But I know it starts from 2b by 5. But I have to find out at y. So upper limit remains y. And then you integrate 5 by 8b dt. So now this is 5t upon 8b for various values of I. Now, what I have done here I am calculating exactly at 2b, which I don't want. When I put upper limit as 2b, what I am doing indirectly, I am finding cumulative frequency distribution at t is equal to 2b, which I don't want. I want in general, what is f of t? Capital F of y. So therefore, upper limit is a variable y whose any particular value if you put, that will be the cumulative distribution of that particular value of y.
Ma'am, it is not like, ma'am, since the small f of y is piecewise defined, then capital F of y will also be piecewise defined. So for values less than 2b by 5, it would be 0.
Yeah. Yes, definitely. Yes. That we have done. So here I'm just finding capital F of y first. And of course, I'll be defining it. Whatever answer of this integration you will get it, that will be defined for 2b upon 5 up to 2b. It will be 0 for y less than 2b by 5. And it will be 1 for y greater than or equal to 2b. That splitting we have to still make it. Let me just first of all integrate. Okay. Understood or not?
Yes, ma'am.
Yeah. So splitting I'm yet to write. Just wait. So when you integrate, the integration of this constant function 5 by 8b is 5t upon 8b. You do upper limit minus lower limit. You will get 5y upon 8b minus, what is the lower limit? Lower limit will be 10b upon 40b. Correct? bb will get cancelled. 10 upon 40 is 1 by 4. So what is your capital F of y? Capital F of y, I'm getting it as 5y upon 8b minus 1 upon 4. 10 by 40 is 1 by 4. So therefore, what is capital F of y? Capital F of y is 0 for y less than 2 by 5, correct? Because your small f is not defined for y less than 2b by 5. Now it will be this function that we have just now found by integration, 5y by 8b minus 1 by 4 for the given range, 2b upon 5 less than or equal to y less than or equal to 2b. And what will happen? So what is the last constant in the cumulative frequency distribution? Up to here only your variable or the domain is defined. No? Your variable y is defined only up to 2b. So in fact 2b is also not included. At last, when y is greater than or equal to 2b. So here, you know, we have done this in the next previous lecture. Here, this interval is always half open, half closed. In the last lecture, I told you how to split it. So if 2b by 5, I include from left, 2b is not included. And for y greater equal to b, you know, last value in the cumulative distribution function is always 1. Shall I show you the yesterday's slide so you will understand more clearly? I think I should. Suppose I take this. What we did is cumulative where we have done. I think cumulative I have done somewhere. Yeah, here I think. Just a minute. When you define a cumulative frequency distribution, here we defined it. So when you write down capital F selectively, this is from yesterday's lecture. This is yesterday's slide. So what was why this bottom line is coming? I don't know. Here there is 1. So last number in the cumulative frequency distribution is always 1 because we are go on adding probabilities, right? 0 to 1 by 6. Then 0 plus 1 by 6 plus whatever is there at 1 and 2, that we will add up and that will sum up to 5 by 16, like that. So that is, therefore it is called as cumulative distribution. At last your cumulative distribution ends at 1 for x greater equal 4. So this I've shown you in the last lecture. So therefore presently what I'm doing is the same thing. Okay, so what we have done is, I think I'm here. Yeah. So when I define a cumulative frequency distribution for this example, for y greater equal to b, the cumulative frequency distribution sum ups to 1. And this is how to find out capital F of y. Okay. Yeah. And what is the next question? So we have found the capital F of y. Why this scroll bottom line is coming today? I don't know. Anyway. So next question is you have to find out the probability that capital X is less than or equal to b. So in other words, they're asking you to find out the probability that the winning bid is less than or equal to DO is preliminary estimate B. So how will you find out probability that capital X is less than or equal to B? That is the next question. How will you find this out?
Capital F of B.
Yeah, so by definition, this is capital F of B, and that is simply, look at this definition just now we have defined. What will be capital F of B? Look at this. Is B lying in between this domain? Yes, because B is less than 2B, right? So you just replace y by B, so it will be 5B upon 8B minus 1 by 4. BB will get cancelled, and it is 5 minus 2 by 8, which is 3 upon 8. So this is cumulative probability at B. Yeah, so this completes the concept of cumulative distribution for a continuous function. Now we are towards the concept of mathematical expectation or a mean of a random variable capital X. So expectation is nothing but the mean. Okay, there are two terminologies: expectation of a random variable, or I may say it as the mean of a random variable sometimes. So let us take an example. Now the example is 2 coins are tossed 16 times. So I will take 2 coins. Okay, I will toss them simultaneously and I will repeat this action for 16 times. And I will define my random variable capital X as a number of heads occur per toss. Okay, so when I suppose so on the first toss, suppose on the first coin I am getting tail, and on the second coin also I am getting tail. Then what is your capital X for this toss? What is capital X? How it is defined? What is capital X in this experiment I'm defining? Bola. What is the experiment, students? Experiment is tossing 2 coins 16 times. And what is the random variable with respect to this experiment I'm defining is number of heads that is occurring per toss. Now what I'm asking you, suppose I toss a pair of 2 coins first time. And in the first toss, suppose I get tail on first coin and tail on the second coin as well. Then what is the value of capital X for this toss?
0.
Yeah, the 0, because I am counting number of heads. Na? How I am defining my random variable is number of heads that is occurring per toss. So suppose on the first toss, I am getting TT. On the second toss, second time when I repeat the procedure, I am again getting TT. Third toss मध्ये आपल्याला TT मिळालं. Fourth toss, suppose I am getting TT. I am considering, I am supposing it. It may not always happen. This is some recorded outcomes that I am writing here. Fifth toss, when you do, you are getting HT. Sixth toss, you are getting TH. Seventh toss, you are getting HT. Eighth toss, मध्ये TH, like that. Till 13th toss, you will get HH, 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 HH. Okay. So this is how my experiment is performed. And I am getting this kind of outcomes in the 16 tosses. Okay, so this is what I have done. I wish to find out what is meant by, or what is the expectation of the random variable capital X, which is defined as number of heads in this experiment. In other words, I'm going to find out mean of a random variable capital X in this experiment, and for these outcomes. Your outcome and my outcome, of course, will be different, but these are my 16 outcomes in 16 tosses that I'm getting. Now, what do you think, students? So, if I see first 4 tosses, I'm getting TT, 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 TT. After that, from 5th to 11th toss, I'm getting only one head. So, value of your random variable capital X from with the toss number 5 to toss number 11 is 1. How many times you are getting one head out of 16? 1, 2, 3, 4, 5, 6, 7 times I'm getting one head. 4 times I'm getting no head, 0 heads. And HH, HH, HH 5 times, right? So how many times you are getting 2 heads? 1, 2, 3, 4, 5 times out of 16. So what is the probability of getting 0 heads in this case? What is the probability of getting 0 heads out of 16 tosses? How many times you are getting 0 heads? 4 times. First 4 tosses, correct? So 4 upon 16 is the probability. How many times you are getting one head from toss number 5 to toss number 11? You are getting one head. How many times it is appearing? 7 times. So what is the probability of getting one head? 7 by 16. Out of 16 tosses, 7 times I am getting one head. And how many times you are getting 2 heads, students? 5 times. So 5 by 16 is the probability of getting 2 heads in this case, in this assumption of the outcome. Okay, so average number of heads per toss, suppose you want to find it out, of 2 coins, it will be 0 into 4, because 0 heads I'm getting 4 times in an experiment when I repeat the procedure 16 times. So one head I'm getting 7 times. 7 by 16 is the probability. 2 heads you are getting 5 times. So 2 by 5 divided by 16. The answer is 1.06. This is average number of heads per toss of 2 coins. So on an average, you can see here, na, here what value of capital X is appearing most of the times. The capital X 7, na, 7 times I am getting one head out of 16. So therefore your expected value or the mean value of the random variable is coming out to be 1.0 something. Means on an average you will get one head. Okay. This is called as expected value of that random variable. Here capital X means the random variable is number of heads. So this experiment motivates us to define expected value of any random variable. Okay, so capital X, when you have to find when you have to find out the expected value of a random variable capital X, generally we denote it by E of X. Okay, so expected value, when you have to find it out, you have to multiply each value of capital X by its probability. So in other words, if you look at this calculation from which I'm getting 1.06, what I'm doing, zero number of heads into 4 by 16, which is its probability of getting 0 heads, plus when I want to when I'm getting 1 head, means the value of random variable is when 1, means number of heads when it is 1. 7 by 16 is its probability, plus when you have 2 heads, 5 times it is appearing. 5 by 16 is the probability of getting 2 heads. So what I'm doing, I'm multiplying each value of X with probability. Okay, so that is what is called as expectation of a random variable, and here the definition comes. So the previous example motivates us to write this definition. So the definition is as follows. So if the random variable capital X is with the probability distribution small f of x, so small f of x is given to you, then the expected value of capital X, which is also called as the mathematical expectation of capital X, or it is also called as mean of x. Let me just write here again. It is also called as mean of x. Mean of x or expectation of x or mathematical expect. These are the terminology. We will denote it by E of x. So what we just now noted, you have to add the values of all random variables x with their probabilities. This is for the discrete case. And in case of continuous random variable, I already told you in the last lecture that summation will get replaced by the integration. So when in case of discrete, suppose you are adding xfx, in case of continuous, you will be integrating xfx with respect to x as a variable of integration. Integration limits are from minus infinity to infinity. All over the real line, you have to define continuous random variable. Is the motivation clear and the definition of expectation clear? Yes. When you have to find out expectation of x or average number of heads that you are getting it, what we did, I am getting 0 heads 4 times out of 16 tosses, plus I am getting 1 head 7 times out of 16 tosses, plus I am getting 2 heads 5 times out of 16 tosses. So what I am doing, this is the value of your random variable x. So when x is 0, this is its probability, plus you are having when random variable its value x, its probability function is fx. I'm finding its probability. We denote it by fx, right? Plus your random when you have 2 heads, it is appearing these many. So the probability is 5 by 16. So what we are doing, I am summing. What I am summing? I am adding xfx. Correct? Therefore, the definition is this. And we call this as expectation of x. So expected value of getting expected value of a random variable x, where x is number of heads is 1 in that experiment. Example, find the expected number of chemists on a committee of size 3 selected at random from 4 chemists and 3 biologists. Tell me, how will you do this example? You have 4 chemists and 3 biologists. So total you have 7 people. Okay. What is your random variable, students? In this experiment, what is your random variable? You have to find out the expected value of what?
Number of chemists
Yeah.
on a committee size 3.
Yes, very good, Shruti. So you have to find out expected number, means expectation of number of chemists. So number of chemists is the random variable. That should be clear to all of you. Correct? Random variable from the question, you should be able to understand. Random variable is number of chemists. Now you tell me range of X. Number of chemists. What are the possible values capital X can take in this experiment? You have to find out committee of what size?
0 to
3.
3.
Yeah. You may have 0 chemists. You may have 1 chemist. You may have 2. You may have 3. We will having the maximum value capital X as 3 because we have to find out the committee of size 3 only, no? Therefore. Yeah. Now you tell me what is the expectation of X, means what is the mean value of this random variable. So what I told you that this is discrete random variable, na? 0, 1, 2, 3. It is not having any formula fx. So it is summation x fx for those values of x. Now what is the first value of x? X is running from 0 to 3, say, here in this case. So 0 into f of 0 plus 1 into f of 1. f of 1 म्हणजे काय? f of 0 म्हणजे काय? 2 into f of 2 plus 3 into f of 3. What is small f of x? Small f x म्हणजे काय? पटपट बोला. Small f म्हणजे काय? Probability that capital X is equal to X. बरोबर ना? The probability function. आता मला सांगा f of 0 म्हणजे काय? First, f of 0 सांगा.
No chemistry.
Yeah, f of 0 means how to read it? Probability of forming, probability of forming a committee with 0 number of chemists. But I have to find a committee of size 3. So all biologists, all 3 should be biologists, 0 chemists. So you will be choosing 0 chemists out of how many chemists? How many chemists in total? 4, no? So I'll be choosing 0 chemists out of 4 chemists, and I'll be choosing all 3 biologists from the 3 biologists. So how to, so this question of finding probability is going towards a permutation or towards a combination? You have to arrange or you have to choose?
Combination.
Yes. So it's a question of combination. So you tell me, how will you write f of 0? This is 0 into what?
4C0, 3C3.
Yeah. Yes. 4C0. So 0 chemists out of 4 into 3 biologists out of 3, whole divided by what? What is the total number of ways of choosing 3 people out of total 7? What is the number of ways of choosing 3 people out of total 7? Na? 4 plus 3, 4 chemists and 3 biologists means total 7 people are in your hand, and you have to in general form a committee of size 3. So what is that number of ways? So you have to divide by 7C3. Correct? Is this clear? f of 0 clear आहे का तुम्हाला? 4C0 into 3C3 divided by 7. I will just go to next page. So 0 into 4C0 into 3C3 will divided by 7C3. This is the probability of choosing 0 chemists plus 1 chemist. Suppose you have to choose, then I will be choosing it from 4. Then remaining 2 should be biologists. Correct? So I'll multiply by 3C2 divided by the total number of ways to choose 3 people out of 7 is 7C3. Can you tell me what is the probability of choosing 2 chemists? From 4 chemists, you will be choosing 2 chemists. But I have to form a committee of 3 people. Na? So remaining 1 person, I'll be choosing from 3 biologists. So 3C1 divided by 7C3 plus 3 into 4C. Now you have to choose all chemists, no? And then 0 biologists. 3C 0 biologists divided by 7C3. So this is f of 0, this is f of 1, this is f of 2, and this is f of 3. Just calculate this answer. I hope you can calculate. And this is 0 into, what is this first f of 0? 1 by 35, I guess. Plus 1 into 12 by 35. This 2 into 18 by 35. Plus 3 into 4 by 35. Is it correct? Yes, it's similar. Someone wrote in the chat box the formula in terms of x. Can you tell me small fx in this case, students? So I think the answer is 1.7 something. The expectation हे check करा नंतर. So suppose in general, what is fx? For this example, x represents number of chemists. Correct? X will take value 0, 1, 2, 3. So what is the probability of choosing x chemists? Where you have to form a committee. Yeah. 4c
x.
x. Yeah. Into 3c.
3 minus x.
Yeah. 3 minus x biologists. Nah. Suppose you choose x chemists. Then of course 3 minus x biologists you should choose because you have to form a committee of 2. So always the addition of these suffixes has to be 3, na? Because you have to form a committee of 3 people. Correct? Therefore, so suffixes that addition has to be 3, which is the number of people whose committee you have to form. And whole divided by 7c3 is the total number of ways of choosing 3 people out of 7. Is the example clear? If it is not clear, type 0. If it is clear, type 1. This course on probability is involved, huh? And it's vast also. So, of course, it is taking time. Complete syllabus is vast. I need to take some extra lecture on Saturday, I think. But anyhow, let us go to next example. Capital X is the random variable that denotes the life in hours of a certain type of tube. So what is capital X? The life in hours. It's our random variable. And the probability density function. Density function means probability mass function only, and density function means probability function, small f of x only, is 20,000 for x greater than 100. So how to read this out? The tube whose life is greater than 100 hours is having a probability function 20,000. Okay. And it is 0 elsewhere. Find the expected life of the tube. So what is the definition of expectation for a continuous random variable? We'll go to the definition. Here it is. So what you have to do is you have to just simply integrate x f x from minus infinity to infinity. Okay. So how will you write this? As expectation of x in this continuous case, minus infinity to infinity x f of x dx. How will you write fx? What is f of x? Look at this small f of x. What is your domain where the small f of x is non-zero? For x greater than 100, it is 20,000, right? Otherwise, the integration value will be 0 because your fx is 0 elsewhere. So what you should write here, what will be the limits of integrations?
It is not a probability density function because integral minus infinity to infinity is not.
Sorry. Yes, sorry. Here I made a mistake. 20,000 divided by x cube is there. Sorry. X cube आहे denominator मध्ये. Now, is it giving you answer 1 when you integrate from minus infinity to infinity? Yes? You're absolutely right. If you integrate from minus infinity to this probability function, your answer has to be 1. No? So can you cross check? First, that integral from minus, it is not in the question. You have to just cross check and verify करा बरं. Integral from minus infinity to infinity of small fx. Is it 1?
No, ma'am.
No, it is not 1.
No.
Okay, I will just check this question again. It's from your textbook only. I will discuss it in the next lecture. But anyhow, you just remember, suppose you have to find out the expectation of a continuous random variable. What you do is just take the integral of x fx, where fx is the probability function, and then you find out the answer. That will be the expected value. So I hope the definition of expectation and the concept is clear. Now let me just go to next step. Now you consider the function gx of a random variable capital X. Now we have a random variable capital X and its function g of x, some function g of x. In this case, let us take x square we are considering. Okay, and capital X is a random, discrete random variable. Small fx is the probability distribution of capital X. Capital X is taking values minus 1, 0, 1, 2. So these are all assumptions just for understanding this concept. Now suppose I have to find out probability of gx. Suppose I'm interested in probability of this function of random variable. So you know we have suppose I start with any function. Suppose capital X is a random variable, whatever it may be. And capital X is taking values minus 1, 0, 1, 2, say. So this is the given thing. These are all given things. And I need, or in fact, I'm interested in finding probability of g of x. Okay. So capital X is the given random variable and some function of that capital X I will take it, say x square. So g is some function of your random variable x. And I'm interested in finding probability of gx. So what I will do, first of all, you have to observe your x values. Your x values are minus 1, 0, 1, and 2. So first value of capital X is, so you know when capital X takes these values, minus 1, 0, 1, and 2, what are the values taken by gx? If capital X is minus 1, what is gx? Function of a random variable, x square we are taking. So if capital X is minus 1, what is gx? Minus 1 square.
1.
Yeah. So let me just make a table. So if suppose first column are your capital X values and the next column is your capital gx values. You know gx is x square as given. So minus 1, 0, 1, and 2 are the values of capital X. Then x square is 1, 0, 1, and 4. Correct? You have to just square. That's your definition of capital Gx. So x square will take value 0, 1, and 4. 1, 1 is repeated. So in summary, a capital X square means G capital X is 0, 1, and 4. These are the possible values. And I'm interested in finding probability that that random variable, its function will take first value 0. Then secondly, your function Gx means x square will take its value 1. And thirdly, there are only 3 distinct values of x square, right? 0, 1, and 4. Thirdly, the probability that your function gx will take value 4. We are not now interested in probability of capital X is whatever. We are now interested in probability of function of that random variable. Okay, so I am having only 3 distinct values, 0, 1, and 4, because we are taking squares and this negative value will get what you can say accumulated inside the value of the square when I take square of minus 1. Yes, so when I find out the probability of that function of a random variable, its first value is 0. It is nothing but probability of capital X square is equal to 0 because gx is x square. I'm just writing gx is x square. And x square is 0 means probability that capital X will be 0. And you know by definition, probability that capital X is equal to 0 is f of 0. Because how we have defined fx, probability that capital X is equal to 0. This is your probability function for a discrete case at least. So therefore, what you do is just find out f of 0. That will be probability that gx will be taking first value 0. Secondly, when I find out the probability that your gx, which is actually x square, is equal to 1, because next value of x square is 1. It is nothing but probability that capital X square, because gx is x square, is equal to 1. So it is probability that x is equal to plus or minus 1, because capital X is plus 1 and minus 1 are included in x square is equal to 1 or gx is equal to 1. So it is the probability that capital X will take value 1 and capital X will take value minus 1. So here f of 1 plus f of minus 1 will be the probability that gx is equal to 1. Yes, Rushikesh, you wants to say something? Thirdly, probability that gx is equal to 4 for third value of gx will be equal to, so what is gx? Gx is x square. So x square is equal to 4 means x is equal to, in fact, plus or minus 2. But is your capital X is taking value minus 2? Look at capital X. What I have given. Is your capital X taking value minus 2? No. Minus 2 is not there in picture. So the only value of capital X corresponding to x square is equal to 4 is 2. Therefore, it is f of 2. Okay. So what we will do is we will just now interested in finding expectation of function of a random variable. So how will you find out expectation of x? What is the definition for a discrete case? It is summation of x f x. In case of continuous random variable, it is integration of x f x. Correct? Yeah. So expectation of gx is the expectation of x square, because gx is x square. Is this clear? First step. Her aim is to find out expectation of a function of a random variable, say gx. But in this case, gx in this example I have taken as x square. But expectation of x square, you know what is expectation of x? Look at this definition. Here I have written in red color. Expectation of x is summation x f x for a discrete case. Okay, I will just take a discrete case so that you will not be having any confusion with this infinity and minus infinity. Anyhow, so this is the definition of expectation. You just apply it for this. Okay, this is gx, no? This x square is gx. That's it. So by this definition, if expectation of capital X is summation x f x, expectation of gx will be summation gx. So you replace x by x by g of x. So x will be replaced by gx. So it will become summation gx, and here also inside f, x will be replaced by gx. So how the definition will look like if I replace x by gx in the definition of expectation? It will look like this. Expectation. So RHS you just concentrate. Okay. So it will be gx summation gx into f of gx. But what is f of gx? How to read this out? Small f is the probability, no? Small f is a probability function that capital X is equal to x. So f of gx is probability that gx is equal to g of small x. Every other term is as it is. But I know gx is x square. And here gx is equal to small g of x. So what are the small gx values that are taken? Small gx values here in the second column, you just look at it is either 0, 1 or 4, because we are taking squares of capital X. So therefore, here you will get only 3 values, 0, 1 or 4. 4 means 2 square लिहिला आहे इथे, लक्षात घ्या. And now you just substitute, because you know small x values are either 0, 1 or 4. So it will be 0 square. So I am now adding separately. It is 0 square, x square, no? Gx is x square. So 0 square into probability that gx will take first value 0 plus 1 square. When capital small x is 1, it is 1 square because it is x square into probability that gx will take second value 1 plus the third value is 2 square, namely 4. So plus 4 means 2 square into probability that gx is equal to 2 square. Now what is meant by probability that gx is equal to 0? Here we have calculated. What is probability? First, probability that gx is equal to 0 is f of 0. So that I will substitute here. Now gx is equal to 1 means x square is 1. Na? Gx is x square means x is equal to plus or minus 1. So therefore probability that x is equal to plus or minus 1 will be f of 1 plus f of minus 1, because x square is equal to 1 means x corresponds to plus 1 and minus 1. So all those probabilities will get add. 1 square is 1 is written as it is. And the last term is 2 square into probability that gx means x square is equal to 2 square means 4. But x square is equal to 4 means x is equal to plus or minus 2. But I don't have the value minus 2 included in the values of x given, because our domain x starts from minus 1. Minus 2 is not there. So only f of 2 will get added. So ultimately what we are getting here is x into the corresponding probabilities. X square into corresponding f of x. Their summations we are getting. But x square is gx. Okay, therefore the expectation of gx is summation gx into f of x. So this example motivates us to write down the definition of expectation of g of x. So you remember that expectation of x is summation x f x, and expectation of a function of a random variable x is summation gx f of x. It is quite obvious. म्हणजे मी असंही तुम्हाला सांगू शकले असते की जर expectation of x is xfx, summation xfx, then you just replace x by gx. That will give you the definition of expectation of gx, expectation of a function of x. But this is the motivation. From this example, it will be clear why the definition of expectation of gx is like this only. So it's not always about the replacing x by gx and x by gx. Some motivation is there. So this is the motivation behind the definition of E of gx. Okay, so in general, the theorem is written. So in fact, we have seen the I should say. Yeah, motivation or illustration, you can say. So in general, if capital X is the random variable with a probability distribution small f of x, then the expected value of the function g of x is summation gx fx. Now, if it is in the case of discrete, in case of continuous, replace summation by integration. So in case of continuous random variable, expectation of a function of a random variable gx is integral from minus infinity to infinity gx into f of x. So take this example, first example. आता मला इथे सांगा आधी हे probability function आहे का? म्हणजे तुम्ही just integrate करा आणि मला सांगा if your answer is 1 coming out or not. Is your answer 1? Minus 1 to 2 x square by 3 dx. Is your answer 1?
Yes, ma'am.
Yes, so this should happen. Then only we will call it as a probability function. Now you have to find out the expected value of g of x, where g of capital X is 2x minus 1. So you just apply the present given definition on the previous page. Expectation of a function of a random variable x is integral of gx into fx. This is a continuous case. So what you do is just simply integrate. What is gx? 2x minus 1. And what is fx? X square by 3 dx only on the now only on the interval minus 1 to 2 your fx is non-zero. So I should not write it from minus infinity to infinity. Your domain will be just from minus 1 to 2. Can you find out the answer later? Expectation gx answer nantar find kartal?
Yes, ma'am.
This is just the integration problem. Motivation, statistical motivation is different. Now you look at this example too. If capital X is the random variable, the probability distribution. Now this is discrete random variable case. Because continuous case मध्ये तुम्हाला फॉर्म्युला दिलेला आहे आणि डिस्क्रीट केस मध्ये तुम्हाला काय दिलेलं आहे? डिस्क्रीट केस मध्ये टेबल दिलेलं आहे. and you have to find out the expected value of y. Means you have to find out E of y. How will you find out E of y? This is E of x minus 1 whole square. Now, how will you find it out? By definition, what is the expected value of gx? Is summation gx fx. So what you will do? Summation gx means x minus 1 whole square into fx. Small x should take. So for x running from 0 to 3, you have to find it out. So it is 0 minus 1 whole square into f of 0 plus 1 minus 1 whole square means 0 square into f of 1 plus 2 minus 1 whole square means 1 square into f of 2 plus 3 minus 1 whole square means 2 square f of 3. What is f of 0? Now we just substitute the answer. So that's it. So f of 0 is 1 by 3 plus the second term will be 0 plus f of 2 will be 0 plus 2 square is 4 into 1 by 6. So what is the expected value of y? 1 by 3 plus 1 by 6. How much it is? V by?
Forms of equation
Is it half? Is it half?
plus 7y is
It's
equal to
2 by 3 is then 4 into
Sorry. 2 is 2 by 3 है. Sorry. So it is 1. Sorry. So expected value of gx means y. X minus 1 whole square is 1 in this case. Now there are some certain laws of expectations and all. I think my time is over. So anyhow, so yeah, in the next lecture I have to cover up the expectation laws. These are very simple laws and some variance of a random variable and its laws. So those things I have to cover. So I need to take extra lecture on Saturday. I am having my second dose of Covishield on Friday. So if I feeling weak on Saturday, I may not be in a position, but I hope so I'll be in a position to take the lecture after taking the dose. So मला सांगा मग एक्स्ट्रा लेक्चर सॅटर्डेचं टायमिंग प्रोबॅबली सांगा. When you are free on Saturday, बोला ना पटपट.
forms of
Can you give
equations
a
पढ़े
proof
ना,
for that?
इसको उस फॉर्म में लाने का है
Can
और
you
फिर
give a
हम लोग
proof
को
for
कंपेयर
that
करने का
which we
इक्वेशन
just
स्लोप निकालना है. ये है स्लोप
to give just
इंटरसेप्ट
the
फॉर्म.
motivation,
स्लोप
no?
इंटरसेप्ट फॉर्म. x
So,
plus
I
What
7y is
motivation?
equal to
very
0. ये तुम्हारा इक्वेशन
that
ऑफलाइन है.
expectation
तो
of
7y
g
is
of
equal
x.
to minus x. तो y is equal to minus 1 upon 7.
So
So
like
what about
I
that
am not
motivation?
क्योंकि स्लोप
feeling
निकालना तो कंपेयर करने का इसको
very
दोनों
motivated
इक्वेशन से, तो
about
हमको
that. So
स्लोप
can you
क्या
give
मिलेगा?
a
m is equal to
like
minus 1.
proof for that?
समझ में आया?
Proof for that
Like,
theorem.
yeah.
Acha. Okay, I will try to give in the next session anyway, but then yeah, okay, I will try. The proofs are not included in the syllabus is already vast, so I have omitted, but I gave the motivation. I have not given you
Concept
Yeah, ma'am,
problems.
you can give in writing also in the group.
Okay.
So that
Yes,
will be
yes, yes.
fine.
Okay, sure. I will give you in the writing because everything I cannot include in lectures. We have very limited time. We have time constraint. Secondly, you just give me the Saturday slots. म्हणजे मला गरजेचं आहे लेक्चर. आय कॅनॉट रन ऑल द टाइम ना. म्हणजे मी तुम्हाला असंही करू शकले असते की मी तुम्हाला फक्त डेफिनेशन दिली असती, एखादं एक्झाम्पल दिलं असतं. म्हणजे हे एक्सपेक्टेशन ऑफ एक्स इज समेशन एक्स डी एक्स, समेशन एक्स एफ एक्स, like that, and just example like that I could do, but then it's a very mechanical lecture, I mean. So motivation takes time, and then understanding definitions is easy. Therefore I spent time on that anyhow, but then what you can say, I need some more time, at least one extra lecture. मी काही जास्ती एक्स्ट्रा लेक्चर्स घेत नाही, पण ह्या सॅटर्डेला घेणं गरजेचं आहे. तो सॅटर्डेला मी 2 to 3 घेऊ का? 2 to 3 PM, म्हणजे मला दुपारी जरा बरं पडेल सकाळपेक्षा. किंवा तुम्ही क्लासमध्ये डिस्कस करा, पण मला शुअर सांगा. अदरवाईज मी 2 to 3 PM ग्रुपवर टाकेल, व्हॉट्सअप ग्रुपच्या. जर मला तुमचं काही आलं नाही सॅटर्डेपर्यंत, तर मग मी व्हॉट्सअप ग्रुपवर टाकेल 2 to 3 PM. ज्यांना जॉईन करायचं त्यांनी करा, मग असं मग ते नको म्हणजे. And secondly, I have to discuss tutorials, I know. So will it be okay if I just record the lecture on discussions of tutorial problems on my own, where the participants will be nil, and then if I share that recording with you? ट्युटोरियलचं डिस्कशन स्वतःच करते आणि तुम्हाला फक्त रेकॉर्डिंग्स पाठवते. चालेल का असं? म्हणजे तुम्हाला वेळ नसेल तर नंतर तुम्ही बघा, तुम्हाला हवं तेव्हा ते रेकॉर्डिंग ट्युटोरियल डिस्कशनचं.
Now if you give
X
the
cos
solution
omega
also, that
plus y sin omega,
रिटर्न सोल्युशन विल बी ओके क्या?
where p is the normal.
Okay, then I will try to write down the solutions in short, or hints, steps, not detailed solutions. Follow those steps, answers like that. Okay. Okay, then by Sunday, I will be giving you the tutorial examples and their hints. And Saturday's lecture 2 to 3 PM. Okay. Otherwise, you tell me the timing. Only on this Saturday. Thank you.